So this video, what I'm going to do is go over the NMR IR spectroscopy worksheet and kind of go through a couple examples with you. And again, this is just getting at the splitting and other things that we've been talking about a little differently. So you're going to need your NMR sheet. And again, a pencil might be helpful because sometimes you're going to make some mistakes as to how you draw them. So my first example here is 3-pentanone. Please note that sometimes you're going to see this as a geometrical figure or something like that. Realize that each end here is a carbon. 3-pentanone should give you a clue as to what the structure is. If it makes you understand it better, then write it out so you can kind of see 3-pentanone exactly what you're talking about here. So again, this molecule has somewhat symmetrical. So the CH3s on the ends, if I were to cut that molecule in half, I could kind of fold it in on itself and it'd be exactly the same. So I have essentially two unique hydrogens here that I need to make splitting patterns in the correct chemical shift. So CH3s again are going to be around that 0.9, and then CH2, well, because it is next to that C double bond O, it is like a carbonyl compound, it's going to be around 2 to 2.7. So again, you might want to kind of look at the shifts before you draw it, but again, it's just going to take some practice as to how you organize your thoughts as to how to put this together. So CH3s are on the end. It has the neighbor, has 2 hydrogens on it, this neighboring carbon. So that means it's going to split into a triplet. So again, draw a triplet somewhere around 0.9. Mark it as a triplet. Again, if you're using colors, then color it in so that you know which triplet or what it is if you have multiple triplets. The CH2 has only 1 neighbor and it has 3 hydrogens. That's going to split into a quartet. And again, because it's next to that C double bond O, it's going to be between 2 and 2.7. So again, somewhere over here is all I'm looking for. And write quartet next to it. So again, there's no confusion. If you want to use a color system, if you want to use something else, you know, if you want to use symbols, do like triangles and squares or something like that, go for it, okay? Now, in terms of numbers, okay, there are 4 hydrogens that see this. This is 6 hydrogens. So technically speaking, your triplet should be slightly bigger. But again, depending upon the splitting, you know, it's talking about the whole area underneath it. So again, I'm just looking for having the right splitting patterns and having sort of the right chemical shift. So number 2 is propanal, okay? Again, if this is confusing, then just write out the traditional way of this molecule so you could see what you're dealing with. So again, propanal is a aldehyde. So I have this hydrogen here, that is the aldehyde hydrogen. This hydrogen here is next to that carbonyl on an aldehyde. And then your traditional CH3, that is kind of on the end here. So because you have a peak, what we call way downfield, because of the aldehyde, okay, and that's going to be 9 to 10, I suggest you just kind of mark off 9 to 10 here and then do a little squiggle mark. That squiggle mark means that it's not proportional as you go across this spectra, and so you could use that to kind of do a break to save you some space. So this hydrogen, again, is the aldehyde hydrogen, and it sees neighbors, okay? So my aldehyde has to be between 9 and 10, but how many neighbors does it have? Well, this carbon is the only neighbor, so that's the good news, but you have 2 hydrogens on that carbon. So that means this, this splitting pattern needs to be a triplet, okay? And it's going to be relatively small because it is just 1 hydrogen. It is just 1 hydrogen. Okay. Then I got to look at, okay, I got hydrogens next to carbonyl. Okay, hydrogens next to C double bond O, so that's going to be 2 to 2.7. and then I have my traditional CH3. So really, I could go 3 here, 2, 1, and 0. And again, didn't draw that all that great. But really, that's the only section I really need to complete. So I do a triplet over here for my CH3s, done. And then my CH2, okay, has how many neighbors? So this neighbor has 1, and this neighbor has 3. So it's going to be a quintet, So 1, 2, 3, 4, 5. So write down quintet. And this is my triplet. Okay. And again, that's yellow so that you can see the notes from there. Okay, so back page, same idea. I want you to skip to the next page, which is where it gets a little bit more challenging. So now this, you are going to be taking a formula, an IR, and then an NMR, and putting it together in the correct manner, okay? So first off, I need to recognize that this is C7H14O. So I could do a degree of unsaturation, and I will get a degree of unsaturation of 1, okay? I have 1 oxygen. I got a C double bond O stretch down here, okay? So I know I'm dealing with ketone or an aldehyde, So I need to flip it over and go, okay, ketone versus aldehyde. This one happens to be 1713, I believe. So that's going to be more on the ketone side. So I'm thinking that this is a ketone, okay? So this is where it gets interesting, okay? I have 7 carbons, but I don't know where the ketone group happens to be. But recognize with this worksheet, they are giving you how many hydrogens are in each one of the peaks. So this is a triplet. This is a sextet, and this is a triplet. Okay. So with this setup, 4, 4, and 6, think symmetrical because those are even numbers. And so that means that that ketone group, okay, the ketone group being the C double bond O, it might be in the middle of that molecule because then if I cut it in half, it might be the same number on each side. So the good or the bad of this next set of problems is you might need to just try things out and see if it works before you can say, okay, this is the answer, okay? So here is my ketone group in the middle of this molecule, and let's see if it matches with the peaks that I have, okay? If I were to cut this molecule in half, I would see that these hydrogens on the end, the CH3 groups, would be there. I would have a CH2 group next door to that. And then I have one right next to that carbonyl. Okay. So if I look at my orange ones first, okay, that would equate to 6 hydrogens. Do I have something that has 6 hydrogens? Yes. What does the orange hydrogen see? They see a neighbor with only 2. Does it make sense it's a triplet? Yes. Where is it on the ppm? It's about 0.9. So that's probably going to be my triplet there, okay, is the CH3s on the end. Then I have my yellow ones, okay? My yellow ones are going to have a lot of neighbors. I have 3 neighbors here and 2 neighbors here. So that would make 6 as my splitting pattern. Does it make sense of where it is? Well, again, the ppms are not going to be easy on you, so you might just need to look at the splitting patterns or what else is remaining in the molecule. Now, this other triplet is in the 2s, okay? And as we have seen, anything next to a C double bond O is going to be in the 2s. So that makes sense that that's going to be that triplet there, because who is the only neighbor? Well, the C double bond O doesn't have a neighbor. It doesn't have hydrogens on it. So this carbon is the only one with 2 hydrogens, which will give you a split of a triplet. So the good or bad of this next section here is going to be the fact that you don't have you really have to try and see if it works, okay? So that's going to be the good or the bad of this next section. All right, so number 7, okay? So number 7, if you can't tell, this peak over here that's around 11 ppm is a singlet, and then you have a triplet and a triplet. And again, the numbers on top tell you how many hydrogens there are. Number 8 is the trickiest one of them all, okay? So if you don't quite get the number 8, do not worry about it too much. So this is a triplet, this is an octet, this is a singlet, and this is a doublet. And then number 9, this is a quartet, and that is a triplet, okay? So see if you could try this packet and see how it goes.